Welcome to our channel. Don't forget to join and subscribe for more insightful content. Today, we'll dive deep into understanding deadlocks in Java. Deadlock in Java refers to a situation where two or more threads are blocked forever, each waiting for the other to release a resource they need to proceed. This can lead to a complete halt in program execution, as the involved threads cannot continue. Now let us understand how deadlock occurs. First, mutual exclusion. At least one resource is held in a non-shareable mode. Only one thread can use the resource at any given time. Second, hold and wait. A thread holding at least one resource is waiting to acquire additional resources that are currently being held by other threads. Third, no preemption. Resources cannot be forcibly taken from a thread. They must be voluntarily released. Fourth, circular wait. A set of threads are waiting for each other in a circular chain. Now let us understand symptoms of deadlock condition. The first way is threads hanging. Threads remain in a blocked state indefinitely. This shows a deadlock situation. Second way to identify is performance issues. The application may slow down significantly as it waits for resources that are never released. Another symptom is resource utilization. CPU and memory resources may be underutilized since some threads are blocked. Okay, now let us understand detection of deadlock. First way is through resource allocation graph. This graph illustrates the allocation and request of resources. If a cycle is detected in the graph, a deadlock is present. Second way is thread dumps. In a Java application, generating a thread dump can help visualize which threads are blocked and what resources. Third way is deadlock detection algorithms. Some operating systems and runtime environments implement algorithms that periodically check for deadlock conditions. So, friends, these are some of the ways by which you can identify the potential deadlock condition. Now let us understand resolution of deadlock. First way is by killing processes, terminating one or more threads involved in the deadlock, allowing others to continue. Second step is resource preemption, forcing one thread to release a resource so that another can proceed. This approach can be complex and requires careful consideration of the implications. Third step could be manual intervention. In some systems, administrators may need to intervene to resolve deadlocks. Now we will understand prevention of deadlock. The first preventive action you can take is lock ordering. Establish a global order for acquiring locks and ensure all threads follow this order. Second one could be timeouts. Implement timeouts on lock acquisitions. If a thread cannot acquire a lock within a specified time, it releases all currently held locks and retries after a random backoff period. Third option could be single lock acquisition. Instead of holding multiple locks simultaneously, try to limit the scope of locks. Acquire one lock at a time when possible. And finally, the last but not least, avoid hold and wait. Require threads to request all the resources they will need at once, rather than holding on to some while waiting for others. Now, to summarize, deadlock is a significant concern in multi-threaded programming, particularly in environments like Java, where threads frequently compete for shared resources. Understanding how deadlock occurs, how to detect it, and how to prevent it is essential for building robust and efficient applications. By applying proper synchronization techniques and resource management strategies, you can significantly reduce the risk of deadlock in your applications. Now we will learn some of related concept of deadlock situation. The very first is sleep method. The sleep method in Java is a static method defined in the thread class that allows a thread to temporarily pause its execution for a specified duration. When a thread calls thread.sleep, it transitions from the running state to the waiting state. During this time, it releases any locks it holds, allowing other threads to execute. After the specified duration, the thread becomes ready again, waiting for the CPU to schedule it for execution. Common use cases are simulating delays. You can use sleep to simulate time delays in applications, such as waiting for user input or simulating processing time. Second use case could be polling mechanisms. In scenarios where a thread needs to periodically check a condition, like a status update, sleep can be used to avoid busy waiting. Now the third use case is rate limiting. When you need to limit the execution rate of a thread, sleep can help control how often a particular action is performed. Okay, now let's understand important considerations for sleep method. First is precision. The actual sleep time may be longer than specified due to system scheduling. The precision of sleep is not guaranteed. Second one is interrupt handling. Always handle the interrupted exception to ensure that your thread can respond appropriately if it is interrupted during sleep. Third is thread management. Overusing sleep can lead to inefficiencies. Okay, dear. Now another important method is wait. Let us understand that. The wait method in Java is used for inter-thread communication, allowing a thread to pause its execution until another thread notifies it that it can continue. It is a vital part of the Java concurrency model, typically used in conjunction with the notify or notify all methods. Key points about wait are: first, belongs to object class. The wait method is defined in the object class, meaning it can be called on any object. This is because every object in Java has a monitor, lock. Second, releases the lock. When a thread calls wait, it releases the intrinsic lock, monitor. It holds on that object and enters the waiting state. This allows other threads to acquire the lock. Third is notification. The waiting thread remains in the waiting state until it is notified by another thread that it can proceed. This is done through the notify or notify all methods. And fourth is, it must be called from synchronized context. You must call wait from a synchronized block or method. If called from outside a synchronized context, it will throw an illegal monitor state exception. Some of important considerations are: first, interruption. If a thread waiting on wait is interrupted, it will throw an interrupted exception. This should be handled properly to ensure thread responsiveness. Second, notify mechanism. If multiple threads are waiting on the same object, the notify method will wake only one waiting thread, while notify all will wake all waiting threads. Thanks for watching. If you found this video helpful, please subscribe to our channel for more Java tutorials and tips. Your support helps us create more valuable content. Hello, dear. Welcome to our channel. Don't forget to subscribe and hit the bell icon to stay updated with our latest videos. Today, we'll explore various Java concepts, starting with Hashmap and Hashtable. A hashmap in Java is a part of the Java collections framework and is used to store data in key value pairs. It provides a way to efficiently retrieve values based on their associated keys. Here are some key features and characteristics of Hashmap. First, key value pair storage. Each entry in a hashmap consists of a unique key and a corresponding value. You can retrieve a value by providing its key. Second, hashing mechanism. It uses a hashing algorithm to compute an index, hash code, for each key, which allows for fast data retrieval. This makes operations like get and put average 01 in time complexity. Third, null values. Hashmap allows one null key and multiple null values. This means you can store a key with a null value and also have several keys mapped to null values. Fourth, non-synchronized. Hashmap is not synchronized, meaning it is not thread safe. If multiple threads access a hashmap concurrently, and at least one of them modifies it, you must externally synchronize it. Fifth, order. The order of the elements is not guaranteed. If you need to maintain insertion order, consider using linked hashmap. Okay. Now let us understand what is a hash table. A hash table is a data structure in Java that stores key value pairs, similar to a hash map, but with some important differences. It is part of the Java collections framework and provides a way to efficiently manage data. Some of the key features of Hashtable are, first, synchronized. Unlike Hashmap, a hashtable is synchronized, meaning it is thread safe. Multiple threads can access a hashtable without causing data corruption. However, this synchronization comes with a performance cost. Second, legacy class. Hashtable is considered a legacy class in Java, meaning it has been around since the early versions of Java. While it is still supported, it is generally recommended to use newer alternatives like Hashmap or concurrent Hashmap for better performance and flexibility. Third, null keys and values. A hash table does not allow null keys or null values. If you try to add a null key or value, it will throw a null pointer exception. Fourth, performance. The average time complexity for basic operations, like put and get, is 0.1. However, due to synchronization, it can be slower than Hashmap in single-threaded scenarios. Fifth, order of elements. Similar to Hashmap, the order of elements in a hash table is not guaranteed. Overall, a hash table is a thread-safe data structure for managing key-value pairs in Java. While it provides synchronization and is suitable for multi-threaded environments, its legacy status and restrictions on null keys and values make it less preferred compared to more modern alternatives like Hashmap and concurrent Hashmap. For most applications, Hashmap is usually the better choice unless thread safety is a critical concern. Now the next thing we will learn, the main differences between Hashmap and Hashtable. First difference, synchronization. Hashtable is synchronized, meaning it is thread safe and can be accessed by multiple threads simultaneously without risk of data corruption. However, this synchronization can lead to reduced performance in single-threaded scenarios, whereas Hashmap is not synchronized, making it unsuited for concurrent access by multiple threads unless external synchronization is implemented. It generally performs better in single-threaded contexts. Second difference is null keys and values. Hashtable does not allow null keys or null values. Attempting to insert a null key or value results in a null pointer exception. Whereas Hashmap allows one null key and multiple null values, making it more flexible in terms of the data it can store. Third difference is performance, in case of Hashtable. The overhead of synchronization can lead to slower performance, especially in single-threaded scenarios, whereas Hashmap generally offers better performance in terms of speed for most operations due to the lack of synchronization overhead. Thanks for watching. Please like the video and subscribe to our channel for more content. Encapsulation in Java is a fundamental concept that involves bundling data and methods operating on the data into a single unit. It is a key principle in object-oriented programming. We achieve encapsulation in Java by using access modifiers like private, protected, and public to restrict access to the class's fields and methods. This helps in maintaining control over data. By using getter and setter methods, we can control how the data is accessed and modified, ensuring data integrity and security. These methods provide a controlled way to interact with data. Encapsulation provides several benefits, including improved code maintainability, increased security, and the ability to change implementation details without affecting other parts of the code. This makes the code more robust. Key concepts of encapsulation in Java include data hiding, access control, and the use of getter and setter methods to interact with private fields. These concepts are crucial for effective encapsulation. Encapsulation also promotes modularity, making it easier to manage and understand complex systems by breaking them down into smaller, manageable units. This modularity simplifies the development process. In summary, encapsulation is essential for creating robust, maintainable, and secure Java applications by controlling access to data and promoting modular design. It is a cornerstone of good software engineering. Encapsulation is a cornerstone of good software engineering. Hello, dear. Requesting you to subscribe to the channel if you are new. Your support helps us create more valuable content for you. Today we are going to learn Runnable Interface in Java. The Runnable Interface in Java is a functional interface that represents a task to be executed by a thread. It is part of the java.lang package and is commonly used for creating threads in a more flexible and reusable way. Key features of the Runnable Interface include its simplicity, flexibility, and the ability to be used with Lambda expressions. Key features of the Runnable Interface are like 1. Single abstract method. The Runnable Interface has one abstract method. This method contains the code that defines the task to be executed when the thread is started. 2. Functional interface. Since Runnable has only one abstract method, it can be implemented using Lambda expressions or method references, which makes it easier to work with in Java 8 and later. 3. Decoupling of task and thread. Implementing Runnable allows you to separate the definition of a task from the execution of that task in a thread, promoting cleaner and more modular code. To use the Runnable interface, implement the run method, create a thread object, and pass the Runnable instance to the thread. Let us understand it. Step 1. Implementing the Runnable interface. You can create a class that implements the Runnable interface and override the run method. Step 2. Creating a thread. Once you have implemented Runnable, you can create a thread object and pass the Runnable instance to it. Step 3. Using Lambda expressions. With Java 8 and later, you can also create Runnable instances using Lambda expressions, which simplifies the syntax. Benefits of using the Runnable interface include better resource management, ease of use, and improved code readability. Synchronization in Java is a mechanism to control the access of multiple threads to shared resources. Key concepts of synchronization include locks, synchronized blocks, and synchronized methods. These help in achieving thread safety. Ways to achieve synchronization include using synchronized blocks, synchronized methods, and explicit locks like reentrant lock. Benefits of synchronization include preventing data inconsistency and ensuring thread safety. Drawbacks include potential performance issues. Please like the video and subscribe to the channel. Your engagement helps us grow and reach more viewers. Thank you for watching the video. We appreciate your time and hope you found the content informative and useful. Access methods in Java determine the visibility of classes, methods, and variables. They control how different parts of a program can interact with each other. There are four main types of access methods in Java: public, private, protected, and default. Each type has specific rules and use cases. Public access allows any other class to access the method or variable. It is the most permissive access level in Java. Private access restricts the visibility to the class itself. No other class can access private methods or variables directly. Protected access allows visibility within the same package and subclasses. It provides a middle ground between public and private access. Default access, also known as package private, restricts visibility to classes within the same package. It is the default if no access modifier is specified. For example, a public method can be called from any other class, while a private method can only be called within its own class. A protected method can be accessed by subclasses, even if they are in different packages. Default methods are accessible within the same package. Understanding these access methods is crucial for designing robust and maintainable Java applications. They help in encapsulating data and defining clear interfaces. By using the appropriate access method, developers can control the interaction between different parts of a program, enhancing security and reducing errors. Please subscribe to the channel to stay updated with our latest content. Today, we will discuss collections in Java and their key components. Collections in Java are a framework that provides an architecture to store and manipulate a group of objects. They are essential for efficient data management. The collections framework includes interfaces, implementations, and algorithms. Key components are list, set, and map interfaces, each serving different purposes in data handling. The Java Collection Framework offers several advantages that enhance programming efficiency and flexibility. Here are some key benefits. 1. Unified architecture. The framework provides a consistent and well-defined set of interfaces and classes for managing groups of objects, making it easier to learn and use. 2. Data structure flexibility. It supports a variety of data structures, e.g., lists, sets, maps, tailored to different use cases, allowing developers to choose the most appropriate structure for their needs. 3. Ease of use. The framework includes utility methods in the collections class for sorting, searching, and manipulating collections, which simplifies common tasks. 4. Automatic resizing. 5. Performance. 6. Type safety. 7. Concurrency support. 8. Iteration support. 9. Built-in algorithms. Generics and collections allow for type safety and eliminate the need for typecasting. They enable you to create classes, interfaces, and methods with a placeholder for types. Common implementations of collection interfaces include ArrayList, LinkedList, HashSet, and TreeSet. Each has its own characteristics and use cases. Iterators are used to traverse through the elements of a collection. They provide a way to access elements sequentially without exposing the underlying structure. Synchronization in collections ensures that data is accessed by only one thread at a time, preventing data inconsistency and thread interference. Custom collections can be created by implementing collection interfaces. This allows for specialized data structures tailored to specific needs. Please like the video and subscribe to the channel for more informative content. Thank you for watching. The final keyword in Java is used to define constants, methods, and classes that cannot be changed or overridden. It ensures immutability and security. A final variable in Java is a constant whose value cannot be modified once assigned. It is often used for constants and ensures data integrity. A final method in Java cannot be overridden by subclasses. This is useful for preventing unexpected behavior in inherited classes and maintaining consistent functionality. Final classes in Java cannot be subclassed. This is particularly useful for creating immutable classes and ensuring that the class's behavior remains unchanged. Using the final keyword offers benefits like improved performance, security, and clarity in code. It helps in creating immutable objects and preventing accidental changes. In summary, the final keyword is a powerful feature in Java that helps in defining constants and controlling the extensibility of classes and methods. There is one more term called finally block in Java. Let us understand that. The finally block in Java is used for code that must execute after a try-catch block, regardless of whether an exception is thrown. It ensures resource cleanup. The structure of a finally block is simple. It follows the try-catch block and contains code that must run regardless of exceptions. It is crucial for resource management. Key points of the finally block include guaranteed execution, resource cleanup, and exception handling. It ensures that important code runs even if an error occurs. Use cases for the finally block include closing files, releasing resources, and cleaning up after operations. It is essential for robust and error-free code. If you found this video helpful, please like, subscribe, and share. Your support helps us create more educational content. Thanks for watching. Inheritance in Java is a mechanism where one class acquires the properties and behaviors of another class. It promotes code reusability and establishes a parent-child relationship. For example, consider a class animal with a method eat. A subclass dog can inherit this method, allowing it to use eat without redefining it. Key characteristics of inheritance include method overriding, where a subclass provides a specific implementation of a method already defined in its superclass. Another characteristic is the use of the super keyword, which allows a subclass to call methods and constructors of its superclass. The benefits of inheritance include reduced code redundancy, easier maintenance, and the ability to create more complex and hierarchical class structures. There are several types of inheritance in Java: single, multiple, multi-level, hierarchical, and hybrid inheritance. Each serves different purposes. Single inheritance involves one class inheriting from another. For example, dog inherits from animal. Multi-level inheritance involves a chain of classes. In hierarchical inheritance, multiple classes inherit from a single superclass. For instance, dog and cat both inherit from animal. Java does not support multiple inheritance directly due to complexity and ambiguity issues, but it can be achieved using interfaces. Hybrid inheritance is a combination of two or more types of inheritance, often implemented using interfaces to avoid complexity. In conclusion, inheritance in Java is a powerful mechanism that promotes code reusability and establishes a parent-child relationship. It includes various types such as single, multiple, multi-level, hierarchical, and hybrid inheritance, each serving different purposes. An interface in Java is a reference type, similar to a class, that can contain only constants, method signatures, default methods, static methods, and nested types. Interfaces cannot contain instance fields or constructors. They are used to specify a set of methods that a class must implement, ensuring a contract for behavior. Key features of interfaces include abstraction, multiple inheritance, and loose coupling. They allow classes to implement multiple interfaces, promoting flexibility and reusability in code. There are two main types of interfaces in Java: marker interfaces and functional interfaces. Marker interfaces have no methods, while functional interfaces have exactly one abstract method. Interfaces are crucial in Java because they provide a way to achieve abstraction and multiple inheritance. They enable polymorphism, allowing objects to be treated as instances of their interface. For example, consider an interface animal with a method makeSound. Classes dog and cat can implement this interface, providing their own versions of makeSound. This ensures that any object of type animal can call makeSound, regardless of whether it is a dog or cat. This promotes code flexibility and maintainability. If you found this explanation helpful, please like and subscribe to our YouTube channel. Thank you for watching our video. Polymorphism in Java allows objects to be treated as instances of their parent class rather than their actual class. This enables flexibility and reusability in code. There are two main types of polymorphism in Java: compile-time polymorphism and runtime polymorphism. Each type has its own unique characteristics and use cases. Compile-time polymorphism, also known as method overloading, occurs when multiple methods in the same class have the same name but different parameters. For example, a class might have a method named add that can accept either two integers or two doubles, depending on the parameters passed. Runtime polymorphism, also known as method overriding, occurs when a subclass provides a specific implementation of a method already defined in its superclass. For instance, a superclass animal might have a method makeSound, which is overridden by subclasses dog and cat to provide specific sounds. Polymorphism allows developers to write more generic and reusable code, reducing redundancy and improving maintainability. This is particularly useful in large-scale software projects. In summary, polymorphism enhances code flexibility and reusability by allowing methods to be used in different contexts, either at compile time or runtime. Welcome to our channel. Today we'll explore static methods in Java. If you're new here, please subscribe for more insightful content. Static methods are functions that belong to the class, not instances. They can be called without creating an object. Key features include no need for object creation, access to static variables, and being called using the class name. Unlike non-static methods, static methods can't access instance variables or methods directly. They operate independently of object state. Imagine a utility class with a static method to convert temperatures. You don't need an object to use this method. In Java, static methods are crucial for utility functions, like mathematical operations, that don't rely on object state. To use a static method, define it with the static keyword. Call it using the class name, like classname.methodName. Today we covered static methods, their features, and usage in Java. Don't forget to like and subscribe for more. Thank you for watching. We appreciate your time and attention. Please do not forget to like the video and subscribe the channel. See you in the next video. Threading in Java is a powerful feature that allows concurrent execution of two or more parts of a program. It is crucial for optimizing performance. A thread is a lightweight process, the smallest unit of processing that can be scheduled by an operating system. In Java, a thread is a part of a process that can run independently. Threads in Java are a fundamental concept in concurrent programming, allowing multiple operations to run simultaneously within a single program. This enables efficient resource utilization and improved performance, particularly in applications that require multitasking or responsiveness. The importance of threading lies in its ability to make efficient use of CPU resources, leading to faster and more responsive applications. This is essential for modern software. Threads offer several benefits, including improved application performance, better resource utilization, and enhanced user experience by allowing multitasking. These advantages are significant. Key features of threads include lightweight processes, shared memory space, and the ability to run independently, making them highly efficient and effective. The lifecycle of a thread includes stages like new, runnable, blocked, waiting, timed waiting, and terminated. Understanding these stages is essential for developers. Creating a thread in Java can be done by extending the thread class or implementing the Runnable Interface, providing flexibility in design and implementation. Thread synchronization is vital to prevent data inconsistency and ensure that only one thread accesses a resource at a time, maintaining data integrity. Multi-threading allows multiple threads to run concurrently, improving the performance of complex applications by dividing tasks and optimizing resource use. However, threading comes with risks like deadlocks, race conditions, and increased complexity, which require careful management and thorough understanding. Please subscribe to our channel and like the video if you found this information helpful. Thank you for watching and supporting us.